Hello, everyone. Welcome to the Carolina Weather Group on this Wednesday, April 18th, 2018, show number 228. And tonight we have with us William Churchill. He is from the National Weather Service in Memphis, Tennessee. We're going to be talking about the GOES-16 and kind of really get in depth with what all GOES-16 is able to help us do here in the forecasting world and maybe some things you didn't know it was capable of doing. So happy to have William on with us tonight. If you are on Weather Twitter, I'm sure you've probably seen a few of William's images float around from time to time on Twitter, and we'll let William kind of talk about that as well as some of the really cool things he's able to do with GOES. So before we do that, this is a live broadcast, so if you are watching tonight and you'd like to interact with us, you can do that one of several ways, actually. Follow along with us on Twitter at Carolina WX Group, or if you're watching on our Facebook Live or Periscope stream, you can interact with us that way by submitting your questions. Or if you're watching on YouTube, we'll be able to monitor those as well. And if you have any questions, we'll make sure to get them to William. And if you're listening on the podcast later on, maybe a week or 2 weeks or whenever from now, we'll let William share his Twitter information towards the end of the show. That way you can interact with William as you need to. So again, this is going to be a really cool show. GOES-16 really helpful and has been really helpful in the past events over the past week with wildfires out in Oklahoma, severe weather here in the Carolinas. It's been a crazy, crazy period. So let's go out west. We'll start with Ashley, who her part of Texas is not really dealing with the wildfires. But Ashley, I know a lot of resources in your area is really focused on the Panhandle area of Texas.
Yes, sir. So we actually sent another set of firefighters out to West Texas. I think this is our second round. They go out for a week deployment, and they usually choose just a general city out there to station in case they have any fire. So we are kind of in the game with that. But as far as weather is concerned here, we're getting into an interesting pattern, more of our spring-like pattern where we have a lot of these systems dropping down, threatening severe weather pretty much every 7 days. So we have another chance at some more severe storms this weekend. Models don't look terribly good to me right now, but a lot of things can change, obviously, being 4 days out on Saturday. The other issue with that is once those systems pass, that really dry, warm air filters in behind it. So we're going to have wildfire risk behind that. So it's kind of like wildfire risk now, severe weather now, every other day. So we're kind of dealing with that here, doing some forecasting. But other than that, it's been great.
All right, Ashley, we appreciate that. Let's go just a little bit to your east, and we'll bring in Eric tonight, who is also in the Memphis, Tennessee area. So, Eric, how's things going there in the good old city of Memphis?
Not too bad. We are fighting between winter and spring here. It keeps flipping back and forth. I think we hit 80 for the first time this spring last Thursday. Got some pretty good storms Friday night into Saturday, dumped about 3 inches of rain. Thunder all a good part of the night on Friday night. Fortunately, didn't get a whole lot of damage or anything out of that. But then Sunday rolled along. We were under the backlash clouds behind the low that moved by, the giant system that was moving off to the east that I know made for some exciting times over there in your neck of the woods. But we ended up tying the record coolest high temperature on Sunday after hitting 80 a few days earlier. It was 47 for the high on Sunday, and that was during the overnight hours. So we've been back and forth, but we're looking at maybe spring sticking around for a little while. Another front moving through as I speak, but it is dry. So typical Memphis springtime, up and down, and it all averages out.
Yeah, I was going to say, Eric, we're expecting that dry front to move through here in the Western Carolinas. I'll talk about our weather since we don't have any other Carolina folk on tonight, and then I'll toss it to our South Carolina boys. But it's been a very interesting week, and first of all, I just want to say our thoughts and prayers are with those in Greensboro who suffered a significant tornado that came through the area Sunday, EF2, and in fact, a couple of weeks from now, we're going to be having Tim Buckley, chief meteorologist at WFMY, Taryn Kirksey, who also works at WFMY, and hopefully someone for the Weather Service to talk about the tornado. WFMI was within a fourth of a mile of the rotation of the tornado, so everyone had to take shelter. And Tim and Taryn was actually doing Facebook Live updates as the station took a power hit. So just devastating pictures out of the Guilford County area. And that tornado actually went on into Virginia and was actually EF3 in the Lynchburg Virginia area as well. So very devastating day across the Carolinas. I think even maybe Shay and Jared, you guys can touch on some of the South Carolina severe weather when we come to you. But we had severe weather on Sunday, numerous damaging wind and large hail and tornadoes. And then Monday, wouldn't you know, the same areas that was under a tornado watch received snow flurries on Monday afternoon and evening as that strong cold front moved through. So my area here in the foothills, we were under tornado watch, had a few severe thunderstorm warnings, and then 24 hours later, it was snowing. So it's been a crazy week in the Carolinas. Thankfully, the weather models look much calmer this week and next coming into the weekend. So really need a break. And again, our thoughts are all those who are affected by the tornadoes here in the Carolinas. And Jared, you and Shay, you guys are also monitoring that severe weather Sunday. So I'll kind of let you guys talk about the South Carolina aspect.
Yeah, absolutely. And it was an interesting one because everything was there for, what could have been, at least on the coastal side, it was feeling pretty good that you could cut through the air with a butter knife. Dews are right there, 68, 69, 70, 71. Got a good bit of surface heating in the morning. The sun was out. And then the cold front did a funny thing, and the squall line did a very funny thing, and it just decided to split. One split went north and spawned several tornadoes up in the Midlands there. And then another part of the line kind of went south and had a couple tornado warnings on the southern extent of it. We finally got that line through, and it caused some sporadic wind damage. But really, all in all, nothing too bad. And the nice thing is that we got almost an inch of rain in some spots. So that'll do a little bit for our drought, but it doesn't look like it's obviously going to bust it very much. But it was certainly windy ahead of it. I was out at a market, and vendor's tent took off, flew about 10 feet, broke in 3 places. Nobody was hurt, but pretty sobering reminder that, 40 mile an hour winds for light things. You got to pick up those light objects. It's pretty critical to do that. But all in all, we caught a break. Now we're just riding the roller coaster. We took a big climb today on the roller coaster. We got about 85 today. In Charleston, going to be about 80, 81 tomorrow, and then back down to 68, and then up to 73 and back down. So basically, I'm just trying to hold my luncheon at this point, more or less, on the temperature roller coaster. Back to you, Scotty.
Yeah, I'll add to Jared's. The front did do a funny thing. It did split, and I saw on radar. I was like, wow, and that whole thing just took off to the north. But the line did reform. I want to share this real quick. This is the Sport SST sea surface temperatures. This spans from March 29th to present, and you can see the cooler shelf waters hugged in right along the coastline. The winds that day were south to south-southeast, so there was a little bit more of an direct onshore flow that was feeding that surface, that cooler, stable air into the surface ahead of those storms. We did get some thunder and lightning. Some of that convection did fire off along the coastline. But it's just a sign that the waters are warming up. We're about 65 degrees now along the cooler shelf waters, all the way up to, say, southern North Carolina and Outer Banks. Still a little bit on the chilly side, low 60s. But for the most part, things really ramped up today on the sea breeze, where we had Bahamian high pressure slide in below that low that Eric was talking about earlier. And that really made for a pretty moderate west wind or zonal flow this morning that panned out as the sea breeze filled in along the coastline. Boy, things really took off, and we're seeing some nocturnal jetting right now along Cape Fear, and even in the Charleston area in Winyah Bay off of Georgetown. And this is in knots, by the way. So, these winds are really cranking up, and this is all jetting ahead of the next cold front. So when you have kind of frontal systems nearby, it tends to do this with the sea breeze. Just another sign that the sea breezes are really starting to kick in from the south this time of the year. But as Jared did say, we do cool down with the easterly flow or east-northeast flow as the northeast wedge sets up from Canadian high pressure or Great Lakes high pressure. So we're looking to cool down again. We may have an extended wind event. The Charleston race week had to cancel the races during that storm, just for FYI mentioned, the afternoon races. And then this weekend is the Fort to Battery race in Charleston. So we're doing a 7-mile drag race across the harbor on anything that goes, anything that sails, kites, sails, boats. Not power boats, but anything that is powered by wind. So that we're looking forward to it. Everything's good here in Charleston, Scotty.
All right, Shay, thank you for that. Before we get to William, I do want to announce some really good news. James Brierton, who you probably have noticed has not been with us for the past couple of weeks, he and his wife had their baby boy over the weekend. Theodore James Brierton was born at Carolina's Medical Center there in Charlotte. So Chelsea and Theodore and James are all doing well, and I believe today they're headed home. So happy for the Briertons, and James wanted to pass along his thanks and gratitude to everyone. And again, Theodore James Brierton was born over the weekend. So congratulations to Chelsea and James. So we told James he could have a few weeks off, right, boys and girls?
One week. I think we said 1 week.
1 week, and then he's got to be back. No, but really good news for those guys. So let's bring in our guest tonight, William Churchill from the National Weather Service in Memphis. I should actually let Eric introduce him because William, you and Eric have got kind of a history together. Eric gave you an opportunity there to work for Memphis Weather.
An opportunity he could not pass up, and he was made a wise decision. Yeah, I've known William for several years now, and has been a great friend and done some great work as an intern when he was at Mississippi State, working for MemphisWeather.net. I think it was 2.5 years that he was helping me out, and like I said, did some really good work, set a nice base there for moving into the National Weather Service here in Memphis, and started off as a pathway student with the Weather Service, and now has got a good gig here in Memphis. So happy to have him close by and leading the charge on the GOES-16 stuff here at the Memphis office. So welcome in, William.
Thanks, Eric, and thanks, Jared. Appreciate that. Glad to be here.
Oh, we're glad to have you, William. And first question before we get into GOES, and I know the guys have a lot of questions for you. We always ask our first time guests, how's your weather story? What got you interested? What's got you to your point here at being a weather service employee there in Memphis?
Yeah, it's always a great question. Well, I first got interested, like a lot of people, real young. I'd say probably middle school. I grew up in Southern California, so we didn't have a whole lot of super interesting weather there. But I remember in particular we had a big flood, and just saw water streaming down my street like a river, and the whole street underwater. And that was the first time I'd really seen something extreme from weather. And so ever since then, I've been interested in it. Watched a lot of the Weather Channel and really got into following the hurricane seasons, even though we didn't get much of that action on the Southern California coast. Got to see what was going on in the Atlantic, and just really loved following that as a kid. And when I moved to Memphis when I was in the middle of high school, about 16, saw real thunderstorms for the first time. I was really hooked from there on out. So it was no brainer for me.
Very cool. Well, you're known on Twitter, weather Twitter is what we like to call it, for your images of GOES-16. So I guess my first question, as we really go into the topic, is what particular interest did you find in GOES-16 to make you want to do like all of these really awesome images that we see and kind of working with all that data?
Yeah, it's interesting. I guess it's just something that happened to be up and coming right when I got in the Weather Service, because I wasn't, I'd taken some remote sensing classes in college and stuff. It wasn't what I was particularly interested in. I was doing more numerical weather prediction prior to that. That's why we used ratios using WRF. So that's kind of where my interest had been. But then, we got the training to do this new satellite coming out, and it just struck me immediately just how crazy the improvements were from the previous generation and how much potential there was, all the new stuff we're going to be able to do with it. So I just naturally delved right in, and before I knew it, saw that I was helping other people in the office to interpret and do different things with it. So it's just kind of where I naturally fell into, and so I just embraced that. And as far as Twitter, it's just whatever I'm looking at, it's just gotten easy enough. I make animations and stuff, so I just like to share whatever I'm looking at, whatever I'm seeing, and I've gotten good response and people like it, so it makes me happy too.
And William, for some of our followers who may not be as connected to the weather community as we are, kind of talk to them about the importance of GOES-16 and really the updates that are brought once we're able to finally understand all the operations that it was given us as meteorologists.
Yeah, well, I mean, the improvements are just, like I said, they're pretty immense. The ones easiest to tackle, the aspects easiest to tackle, I think, are the the increased spatial resolution. So you're getting, more data, more pixels, and then you're getting increased time steps, so temporal resolution too. So those benefits are pretty obvious and straightforward. That you see how much that reveals just having that increased resolution. So like all the little features and stuff we're able to pick out on a normal basis now that we couldn't see before is all pretty incredible. But I think the most fascinating upgrade is spectral resolution. So we had just 5 bands on this previous imager, and now on the new one we have GOES-16. Just coincidentally happens to have 16 bands on it, and it's difficult to say the least if you wanted to look at all 16 of those at once. So what's so cool about the RGBs is it takes that spectral resolution and it filters it down in a way that you can, as a forecaster, look at one thing really quickly and get a lot of information out of it instead of having to go through manually each channel and then try to get some information out of that. So that's what I've been really interested in looking at, is different ways to use those RGBs in an operational environment when time can be very important. You need to do things very quickly. So
what kind of RGBs have you really enjoyed experimenting with? And I guess explain kind of what an RGB is to those who are haven't really used them yet.
Yeah, so that RGB is just referring to red, green, blue, and basically just one way for your computer to interpret how it's going to color a pixel. And the way to interpret it with an RGB is you are basically either placing a channel or a difference in a channel in each of those components. You have a red component, a blue component, a green component. And so, yeah, there you go. Put something up there. So there's the different bands. And so you can basically set each of those bands to be in their own component. And then based on the colors that come out, you can actually reason. It's not just a pretty color picture necessarily. You actually reason why something is one color or not. And that way, you familiarize yourself with what you're looking at, and you can quickly pick out things that that you're looking for that way.
Yeah, and how have you, you're getting started with these, and you're working through them. How did you get started really working with the RGBs?
So I guess how we first got started, we had like a baseline that came with them when we first started getting the data. And actually in our software, we don't have as much freedom as I would like to actually go in there and edit the RGBs. We can kind of just control the extent that each component goes into it. So you don't have a lot of control in terms of which channels are going into which components. Those are sort of pushed down to us. But we do have quite a few in there, and so there's been a lot to experiment with. And in particular, the newer Cirrus natural color one, it's nice having that built in AWIPS, and just those full disk images are awesome to look at.
Definitely. So what RGBs have you found have been most useful so far in your operations?
I would say definitely the nighttime microphysics. Everybody loves that. And as the name implies, you can only use that at night, so it's not very useful during the day. But that's probably the number one at night. That's in particular for weather service operations. It's great for being on the aviation desk and writing TAFs, and you could really see a lot more than you were previously able to with that nighttime microphysics. It really illuminates the stratus and the fog, so you can see it very easily. You can we're lucky enough in Memphis to have one of the default mesoscale sectors over us, so we get that 1 minute data, and so that's extremely useful. Getting those 1 minute updates for monitoring fog development. So that's definitely one of my favorites, the nighttime microphysics. During the day, we have one called it's kind of similar to the nighttime microphysics because it uses that same fog difference channel. But during the day, you flip it, you do the difference the other way around. And so I think it's called a day snow fog RGB. So I like that one quite a bit. It still highlights where the ice clouds are, for example, but gives you more of the natural colors, and the snow stands out really well as a red on there.
Does the nighttime physics, does that help with tracking like latent heat release or radiational cooling, any of the like vegetative release at nighttime during the warmer months, or is there any more application for that feature other than fog?
Yeah, I would say definitely so. One of the interesting things I was noticing on that early on is really anything that the shortwave infrared channel is going to pick up, you're going to see that as a signal in some form on the nighttime microphysics RGB, since it's pulling in that channel in the green part of the image. So that's what really illuminates the fog in the low stratus, that 3.9 channel. But it's also really good at picking up fires, so you're still going to see a fire signature that's going to bleed through the RGB. But similarly, on very cold nights, you can just have heat release from, we have steel plants in our CWA that have some heat release. We have the Valero refinery in Memphis that puts out a pretty good signature for that as well. So that warming on the 3.9 bleeds through on the RGB. So you see like these little flickers of red, essentially, where these hot spots are, whether they're real fires or these, industrial releases. So and that's part of the interesting part of using RGBs. You stumble upon things you might not have seen otherwise because you're incorporating in all these channels. So any difference, anything that's picked up on any of the channels that are incorporated into the RGB, you're going to see that as some sort of anomaly in the satellite imagery.
That's just amazing. I can see it down the road where you'll be able to detect a grill in the backyard.
Yeah, I think one of the crazier things I noticed recently is we had a really clear day where you could actually see on the visible channel, the red channel that has the highest resolution, 0.5 kilometer, I believe. You could see the reflection of the sun off the pyramid. So we have the pyramid in Memphis, so that really big reflective surface. You actually see several of the pixels light up from the reflection off of that. So yeah, we're not far from, I'm sure the next generation of GOES will be able to see very crazy small things that even beyond what we're seeing with this.
Yeah, I'll second that comment that you made about particularly the aviation application with the nighttime microphysics, being in the aviation sector, and having to work with just kind of the plain old fog imagery that we had with the legacy systems. The resolution was not great, and a lot of times you kind of miss the edges, especially of where a stratus deck is and so forth. And this makes a huge difference. You really, with the higher resolution, the higher update rates. I've seen some studies that have been done on, for example, the stratus in the San Francisco area, which you're obviously familiar with from being in California as well. But being able to predict when that's going to move out, and it actually changes the arrival rates at the airports out there and gets them out of delays quicker by being able to see exactly when that's going to happen. So some really cool advancements that have been taking place with that.
William, one question that we had a couple of days ago that I was monitoring. Some of the folks are wanting to know what the different bands are. I think there's 16 bands in GOES-16. You don't have to go through all of them, but what are some maybe of the important ones that maybe those meteorology students or those people who are interested in weather that they should be monitoring? Maybe what kind of information those give out?
Yeah, so the easiest way to break them down and understand them, you can break them down into their groups. So, because there's 16 of them, but some of them are a little redundant in the tasks they do, and you don't necessarily need to be familiar with every single one of those bands. But the three important groups, I would say, are the first group, with the shortest wavelengths, which are going to be your first and second channel, or the visible channels, and that is blue and red, and they're just called that because they're sensing the radiation at where our eye sees blue and where our eye sees red. It's sensing the radiation at those particular wavelengths. So those are your two visible channels, and so those require daylight to operate because at night there's no light for the satellite to pick up, simply enough. Right, so on the chart there, that's going to be number 1 and 2. And then we get into a whole new class of bands, and this was one of the more revolutionary things about GOES-16 in terms of the spectral capacity increasing, is we have these near infrared bands. So that's going to be channels 3, 4, 5, and 6. And all of those bands there are near infrared, so they're going to still require solar reflectance to be used. So at night, those channels are going to go dark as well. However, they're outside of the color spectrum that our eye sees. So that's why they're near infrared. They're not in the visible spectrum itself. Now, those have some interesting characteristics to them. The veggie band, for example, that gives off very high reflectance on vegetated surfaces and very low for water. So you can see the contrast there in that little image of band 3, where you have the water is much darker than the land in comparison to the bands 1 and 2. So that helps making a lot of the daytime imagery happen the way it does. Then you've got an interesting band, the Cirrus Band. So that band absorbs a lot of water vapor, so everything appears dark other than the cirrus near the top of the atmosphere. Then you've got a snow ice band, and that one's interesting because the ice particles are very absorb a lot at that wavelength, so they show up dark. So that wavelength's kind of counterintuitive if you look at it, because it's all the things you would normally expect to be bright dark, and the water droplets show up brighter. So that's kind of hard to wrap your head around. And then you have the cloud particle size bands. That's similar to the snow ice band. So those are the 4 near infrared, as we call it. And then the remainder of the bands, 7 through 16 there, are all different regular infrared bands. They're not the near infrared. They're just part of the regular infrared spectrum. And you got a couple different purposes in bands there that you can break it down to. You can call them the absorption bands, which are the water vapor bands. So those are actually detecting what's happening at a particular level, which is going to vary. Whereas the clean IR band, the legacy IR band, the dirty IR band, those are all window bands, we would call them. So you're just seeing whatever top is there, whether it's a cloud top or the surface, wherever the satellite is seeing down to, that's where you're detecting the radiation and getting the signal from. So those long wave bands have a little bit of a different purpose too, compared to the absorption ones, the water vapor bands. So, but there's ways you combine these in all sorts of clever ways for the RGBs, and that's really all an RGB comes down to. It's just taking some of these bands and condensing that info down, and then you get a prettier picture to look at too. So it's a win-win.
So the Weather Service uses what's called AWIPS-2, and they kind of migrated from AWIPS to AWIPS-2, which it's not something that's publicly used for meteorologists all around. And I'm going to show something that a lot of us have been using lately, which is the College of DuPage. And this they've really done a great job with the GOES-16 here. And they have all of your bands here on the left side, all the different frequencies, everything that you could ask for, including the nighttime microphysics. And this is sort of what it looks like. So when we're kind of looking at satellite, Weather Service, like I said, uses a different program. But can you tell us a little bit maybe about how this product would work if somebody wanted to go to College of DuPage and use it?
Yeah, and this is my favorite website to look at it from home. So obviously love to at work. And I think one of the benefits at work on AWIPS, and really just one of the benefits of AWIPS in general, I'm sure Jared could attest to, is your ability to zoom and pan, and you have no restrictions on your domains, whereas on the web you have to. That's the one downside. But the College of DuPage has done a great job with those sectors, so they make it really a lot more enjoyable to use at home, because you can quickly go in and zoom into a sector, and you can get a reasonable zoom in exactly where you want it, so you can actually make use of all that increased resolution you're getting from the GOES-16 data. So yeah, I would say first off, look at your sector category there. And that's another thing that's so cool about the satellite imagery, is there are things to look at on a variety of scales. And I love that full disk view where you can see, from pole to pole, everything that's going on. And there's a lot you can get from that large scale. And you can bring that all the way into these localized sectors and these mesoscale sectors, and be looking at individual cumulus clouds forming during the day in your region. So just the difference in scale that you're able to look at there.
Yeah, it's a really fun kind of fun toy to play with, but it's just fascinating. We're just absolutely love the whole new GOES-16. The new GOES West is going to be coming up pretty soon. So that's yeah.
Hey, Shay, you had that pulled up. I was going to see if William could comment a little bit on the lightning detection that GOES-16 provides, and how that's helpful to you guys in the forecast office.
Yeah, that's really a game changer. How much of that lightning data we're getting now. I mean, we're kind of overwhelmed with all the sources we have for it now, but I would say the lightning mapper is kind of the going to be the one standard of lightning data now, at least in terms of its ability to detect lightning in all places, you know, not necessarily just where the ground detectors are. So it's more of a universal lightning detector. And yeah, that's one really great thing about College of Page 2 is you can put that on there. Where do you do that again? I forgot myself where you turn the lightning on.
Oh, that's under the products overlays right
Oh,
here.
the overlays there. Okay, so on the top
So
left.
there's a whole bunch. You can even get composite radar on it now. I mean, you know, there's the storm line with the lightning, and you can sort of layer everything, and it's fantastic.
Yeah, that's great. That's one thing. Funnily enough, we still don't have that in our own systems at work. So we have sort of these provisional websites through NASA Sport. We can use it a little bit on the web still ourselves, but they're having some issue getting it integrated into AWIPS. So I'm not sure what's taken so long. We'll have that soon enough. And with GOES West, we're going to have incredible coverage with these new satellites. It's going to be great.
And William, with one of the big stories in the weather community and the weather world is the use of GOES-16 with wildfires. And, you know, obviously Oklahoma, Texas, like Ashley was talking about, dealing with those conditions. So can you maybe talk to us a little bit about how that is helping you guys in the weather office and maybe even help firefighters as it detects new fires that take place?
Yeah, absolutely. It's been really useful for us in our office in particular. It's not as wildfires aren't as big a thing in the Mid-South as they are out west, but certainly we have you know, spot forecasts that we do. We have controlled burns going on, and so we're able to see those as they're happening. So, you know, we get a spot request and we see a fire pop up, we know, okay, that's supposed to be there. So it's good confirmation for us. And then we're able to monitor it. And if they have any questions, they're able to reach out to us about it. And having that capability is great. And offices like Norman that are dealing with these things on much bigger, more dangerous scales with these wildfires, you know, threatening lives out there. It's been fantastic for them. Like you said, they're able to actually have their notification system. They've developed a notification system where they've actually been able to contact the relevant emergency managers that need to know and say, hey, you know, we've detected this fire out there. And there's been cases where they've been the first ones to let them know and they wouldn't have known otherwise. So that's pretty amazing that we have this piece of technology that's able to provide that info to them.
And Ashley, I was going to ask you, I was wanting to bring you in on that because I know we talked about wildfires a couple of weeks ago, but maybe for those folks who didn't see our show, as an emergency manager, I know you know about GOES-16, but there may be some in that community who's not as familiar. So how useful is that for you guys?
It's very, very, very useful. And I was going to say, I actually have several bookmarked different GOES-16 sites where I do monitor on days that we might have red flag warnings or we might be concerned about fires. I have it pulled up on my second screen, watching for smoke plumes. It's been shown they find those fires before anybody even calls it in. And when it comes to fire response, especially when you have high winds in the 30s and 40s with gusts and very dry fuel, these fires can move very quickly. So every minute that we can get a jump on resources and getting people out there is very beneficial to whether we save more property or whether we save more lives. So it's absolutely great. And I'm currently working with the National Weather Service on monitoring as well. So if we have a bad day, I usually reach out to them on NWS chat and they help us monitor too. So we kind of have a two-way system going on, but I'm so excited about GOES-16. And I think I mentioned last show, a lot of the firefighters I work with have seen the data. I've showed them some smoke plumes and they are very excited about it. So I look forward to kind of teaching them the ropes and showing them the basics of using this tool.
That's awesome.
Mm-hmm.
It is. And so William, as I think we're now, a year and a half into the operation use of GOES-16, I believe it was Shay who, maybe it's Shay or Jared who mentioned GOES-17 that was being launched. So what can we expect from that launch and how will that better help us? I know it's going to help our friends to the west a little bit more than maybe here on the East Coast.
Yeah, that's true. We won't get as much out of it here on the East Coast in terms of the data. Whereas the better data is still going to be coming from the East one. However, one of the big benefits is going to be with it being out of the Pacific Ocean. One, we'll get the nice hurricane pictures in the Pacific. But two is the increase in model data that'll be going, or satellite data that'll be going into the models. So, models assimilate that satellite data in. You get motion vector winds and things like that from the satellite. And so one of our biggest data sparse areas is out over the Pacific, and that's also upstream of where most of our weather is. So the better data we can be getting upstream, the better that's going to help our models and improve their forecasts. So even though the benefit won't be as direct, we've been getting all this awesome data for a while now from GOES-16. It will have subtle, harder to measure, but noticeable impacts on the quality of the models and the model data.
Is there going to be any overlap between the GOES-17 and GOES-16?
Yeah, I think there will be. Certainly in the full disk views of them both, you're going to have a huge overlap. But even in the CONUS, they separated a good bit, but there will be some overlap in the middle there. But I'm looking forward to those composite images, stretching from essentially the Central Pacific to Central Atlantic. Having that full view is going to be really awesome.
So, William, you also obviously there's two mesoscale sectors that are part of the part of each one of the satellites, and so we can get 1 minute imagery from a kind of a more defined area through those mesoscale sectors. So, with having two of those satellites up there, I guess we're basically doubling the mesoscale sectors that we could have in 4 areas that could be getting data every minute. Then I suppose, right?
Yeah, that's right. And those aren't limited to the CONUS sectors either. So even though the CONUS sectors will be separate and different on those 2 satellites, the mesoscale sectors can be placed anywhere on the full disk. So certainly in theory, you'd be able to overlap those even more. I'm not sure if that's in the plans in terms of, stacking 4 on another and getting, whatever even that would be. I think you get down to 30 seconds with the stacking of 2. So you would get down to, I guess, less than 15 seconds a scan if you would time all that right. But yeah, we'll have 4 separate ones. So I don't imagine we'll be stacking them off and to give higher than 30-second updates. That's pretty much as good as it gets.
I would think that would challenge AWIPs even more than what you've already been dealing with.
Yeah, exactly. Not sure you can handle that.
So yeah, what to do with all that data too? Wow.
Yeah. It's pretty impressive. I think it's like a terabyte a day, I want to say, off the top of my head, that comes in from it. So it adds up quickly.
So one more question I'll ask you. I know you haven't been in the Weather Service a long time yet, and to be able to kind of see what operations look like pre-GOES-16. But from the perspective you've got and from what you've seen so far, from the operational side, what have been maybe the top 1 or 2 benefits that have come out of having the GOES-16 data besides, you just having a wealth of data available? There's specifics that, you think have really made some pretty big improvements in operations by having this up there?
Yeah, absolutely. I think what we talked about a good bit from the aviation standpoint, can't tell you how many times I've been shocked that it comes down to where is that leading edge of the stratus or leading edge of the fog. And in fact, you're able to monitor that in so much more real time and with higher frequency, I think helps a lot with aviation for sure. And we talked about the wildfires. I think those are certainly 2 major areas right there that it's helped with. I'd say a third we haven't talked about as much, that it's certainly been useful. And particularly, we even had our radar down recently. And so in situations like that where you have less radar data, the GOES data has been really helpful with those 1 minute mesoscale updates, basically monitoring the updrafts. And so prior to storms forming, if you have visible imagery, if you're lucky enough for it to be daytime during your severe weather, which we don't have as much around here, you're able to monitor that cumulus development, so you can actually see when a storm is getting close to convective initiation or not. And then also the infrared imagery, having that 1 minute data and seeing the cold cloud tops and monitoring that. So there's been several situations in warning operations where I've noticed the cooling cloud tops on the 1 minute data prior to actually seeing the reflectivity jump in the radar data at the higher tilts. So oftentimes that could be a precursor to that. So that could set you in on a storm that's intensifying and that you need to keep a closer eye on, essentially. So yeah, those are just a few. I think some of the less obvious benefits too, kind of just the more shocking things, is how much we're able to see, like after a flood, after we got all that rain in February, for example, seeing the swollen rivers before and after, and just having that real-time view of the waters like that is pretty fascinating too.
Yeah, I know the GOES-13 had some decent satellite view, but this one for this year, especially down in Charleston when we had our snowstorm in January, the high albedo that it created with reflective properties all across from Savannah all the way up. I mean, the snowpack shows up brilliantly, just amazing. You know, you can track snowpack and snow melt. I don't know how far north that goes. Does that go all the way up to Canada and Alaska as well?
Yeah, you get more distortion essentially since you're getting farther away from the point where the satellite's measuring. But yeah, you all the way up full disk. That's a pretty awesome aspect of it, and it's one of those near infrared channels, that snow ice band, where typically when you see on those RGB products that really brilliant difference between the snowpack and the bare ground, that channel, just check that out sometime when there's snowpack, and you can see it's just this big dark splotch how the snow shows up. So it's pretty cool how we're able to do that, just adding that extra sensor to detect that particular wavelength.
All right, guys. Well, we're getting close to 9 o'clock, so I know it's about time to log off here. Does anybody else have any questions as we finish up our conversation? All right. Jared?
You know, William, one last thing. You know, I see you. You know, you do a lot with the creamsicle RGB, which is differential water vapor and things of that nature. I'd love to get into that for a few minutes and just if you're finding that you're using that more or less than you would be just your traditional water vapor channels, you know, in your operations and as you're working just a regular day.
Yeah, I'd personally like using it as more of a first glance. I think you can pick out features just as well in that RGB as you can any one of the in particular water vapor channels. So I like to have it as my default for that reason. One thing I really like about it is on a typical water vapor scale, what you're getting is a brightness temperature as your readout. So you can sample the pixel and you can see, you know, what temperature is this that I'm reading at. But with the RGB imagery, since it's synthesizing a difference of those channels, any of those channels that's getting the same readout, so like a cloud, for example, each of those water vapor channels, it's going to be seeing the cloud at the same temperature since it's actually reading the cloud and not the surrounding air at whatever various level. So as a result, it's going to paint every cloud white in the differential water vapor RGB, whereas in the regular water vapor, it's dependent on what your color scale is, since you're just reading out a temperature. So I think it's a more intuitive way to look at the water vapor channel, but it's a little more mucky because you don't know exactly at what height you're looking at. So I think you get less specific details like that, but I think it makes a better first picture to look at. And then if you want to look at a particular detail in more depth, a lot of times low-level water vapor provides that best image. So I'll pull that up, and then you know that'll see the lowest in the atmosphere, and that's typically where you're looking at a more precise look. But overall, I think the creamsicle RGB is the better way to look at it.
I like it.
All right, William. Well, we appreciate you joining us tonight. And if our followers want to get in touch with you via Twitter, how can they do that?
Yeah, you can follow me at Kudrios. It's Kudrios. And if you're wondering, that's just an old username I've maintained forever. So stubbornly sticking with it.
That's cool enough. Well, hey, stick around. We do a little segment here called Tweet of the Week. So where each of us pick out kind of a tweet that caught our attention over the week. So if you'd like to participate in that, I'll let you look through your Twitter account right quick and you can pull one up. So Eric, sorry, said what a great lead into his Tweet of the Week. So Eric, I'll let you go ahead, buddy.
All right, and I am going to plug William's material tonight by doing the tweet of the week as well. So, William, you can't pick the one that I'm picking right now, even though it's yours. We were just talking about the creamsicle water vapor differential, and this one comes to us from the bottom side of the Earth. This is and hopefully it'll loop here, showing southern hemisphere, and of course we see the high pressure rotation counterclockwise and the low pressures rotating clockwise down from the southern portions of South America there. So I thought this was not only is it great use of the RGB imagery that William's been talking about and just talked about, but from a place that a lot of times we don't necessarily take a look at. So sometimes it's good to remind ourselves that the toilets flush the other direction when we're looking at the bottom side of the Earth.
All right, that's really cool. Thanks, Shay or Eric. I'll go to Shay next. I see he has his pulled up down here in the little bottle box. So Shay, go ahead.
Well, let me take myself off mute there. Yeah, so you know Dakota Smith, he's working with Weather Nation in content production, and but outside of that, that dog will hunt. I'm telling you, he is a GOES-16 fanatic, and he caught this today. Thunder sleet across Iowa this morning, and you can just see the convection firing off in the morning and then shifting direction. But just a detail that you can get so close in and see this detail. And of course, he's probably using Global Lightning Mapper, the GLM product, to see the lightning. And so now things that used to be kind of elusive are not so much anymore. But just an amazing tweet from him. He always seems to have something really cool from GOES-16 on a daily basis.
And Shay, I've seen on Twitter today from that specific storm you're talking about. That was a severe thunderstorm warning with sleet and freezing rain wrapping in behind that storm. So the crazy system going on in Iowa. So thanks for that tweet. I think I see Ashley's tweet up. So Ashley, I'll let you go next.
All right. So this week I'm showcasing my good friendly office, NWS Austin San Antonio, and we're looking at a radar loop of what looks like a strange storm, but is not, because actually our radar was on clear air mode and got switched over by bats. So the Austin bats and the Hill Country bats is kind of a big deal because they get picked up on radar on clear days all the time. So these are actually bats flying out for the evening that triggered our radar and look like a storm. So we share these loops all the time. It's really cool. And I've actually gone out and you can go onto an Austin bridge and watch them fly out over the river. It's a really cool tradition that we have around here.
That is so cool, Ashley. We get those over here in the southeast region, and I think they're purple martin birds, and they produce these gigantic roost rings that they're going to be starting pretty soon, like any morning now. And so Jared, keep your eye out for those because they're really, really cool. And they blow up and people freak out about them and they say, oh man, sometimes you can get cicadas and bugs to do a few smaller rings, but usually the purple martins, and they look like the bats. It's just amazing. I love it.
Yeah, they're already starting. So
are they?
Mm-hmm.
Jared, I'll let you go next because this kind of was a very interesting tweet and a good way to look at things. So go ahead.
Yeah, this is awesome. So Brad Panovich, our buddy Brad, he posts, cupcake watch, no confusion between a watch and a warning. So a cupcake watch is the ingredients are there. Conditions are favorable for the development of a cupcake. Could be a very sweet situation there. A cupcake warning means the cupcake is actually occurring, has been spotted by trained cupcake spotters, and that you should take cover and put one in, ingest one, in a safe, sturdy location in a site-built structure. So this is a great way to put it. I think this is fantastic. If I had a nickel for every time I've been tagged in this one, I'd have about 15 cents. It's a great way to really visualize the difference between a watch and a warning. Now, I have a double feature tonight. So our friends at Helicity Designs followed up on this with a new shirt called Cupcake Debris Signature. And Lord knows have I generated plenty of CDSs in my lifetime.
That's pretty awesome.
Hey, and Rick Smith from the Norman office actually followed up on that and said, you won't always see the tornado itself during the warning. Sometimes it's radar indicated, and there's a signature of it, and so sometimes you can smell the cupcakes from a different room being baked in the oven, and that may still trigger the cupcake warning because those ingredients have been put together, and maybe it hasn't been seen by those cupcake spotters yet. So.
Absolutely.
Gosh, you guys and this food, you're making me hungry.
Yeah.
Again, where's our Cinnabon?
Where's
Exactly.
Peter at with Cinnabon?
Oh my goodness. Yeah. Again, it's very important, when to take cover immediately in your safe room when you're around cupcakes, because Lord knows my doctor wants me to eat less of them. So
thank you for that, Jared. I'm going to share mine right quick, and I apologize because I don't want to butcher Dennis's last name, but this is Weather Dam on Twitter. I'm sure a lot of you guys follow Dennis, but he lives just outside of the Greensboro area, about 15 miles or so in Reedsville. And so Sunday night, he tweeted this picture out. And again, this was the tornado that moved through Greensboro a good 15, 20 miles away, and debris was located in his front yard and parking lot or parking area where he lives at. And again, that was 15, 20 miles away from where the actual tornado hit. So again, that just kind of shows you the severity and just how much where that tornado hit a very populated area with a lot of homes and stuff like that. So that is my tweet of the week. Just the debris that was lofted in the tornado and disposed of 15, 20 miles away from the actual touchdown area. So that's my tweet of the week. And we'll finish up with William. And William, what's your tweet of the week?
Let's see here. Get this pulled up. Can you see that?
Yes, we got you.
All right. So I've got the NextRad Radar Operations Center, the ROC, has been tweeting a few times this week. I think this is their latest one 6 hours ago, of the Ray Dome in San Juan coming back up. So I think that's been awesome to see. And it's, they definitely need to get that thing up there and working before hurricane season. So that's my tweet of the week.
Definitely so. And I heard the news out of Puerto Rico of another power failure there. So the bad news continues for those folks. So we hope that they get that situation fixed fairly quickly. Will you guys have anything before we close out?
That was. I'll just add another very interesting use for GOES-16. Certainly, when after the hurricane took out the radar down there, they were putting the mesoscale sector in the fall down over Puerto Rico and using that for nowcasting and so forth of thunderstorms and stuff, because it was still that season down there when the radar went out. That's the only one they've got down there. So pretty cool use of the high temporal resolution of the satellite.
Yeah, Eric, and I remember that they actually issued a flash flood warning based off of, it said satellite data indicates the possibility for flash flooding. So don't see that very often in a warning, but it was great. They pushed GOES-16 into operations a little bit sooner at the San Juan backup offices for sure. So
yeah.
Did they get any scans from the NOAA planes? I can't remember if they did a few composite scans over the area. Anybody?
Speaking of the,
it would be nice to get more radar down that area. I mean, Martinique got sacked a couple days ago, really bad. They had some serious flooding down there, and there's just no radar in just about all the Caribbean. I mean, you got Puerto Rico. Go ahead, Scotty.
I was going to say, speaking of the NOAA flights, I don't know, did you guys hear the Vortex Southeast, where one of the pilots actually LSR'd a tornado from them flying around down there, and the pilot actually spotted the tornado on the ground, and that was the actual LSR. I think it was in Mississippi or Alabama, one of the two areas over the past week. It
was in Louisiana.
It was
really cool.
That's right. Yeah, so that's really cool. I mean, who would have thought we'd have been in the day where we could have NOAA spotting tornadoes from airplanes. So, all right. Well, let's talk about next week's show. We have Andrew Locano on from the National Weather Service in Blacksburg, Virginia. We're going to be talking about the new enhanced hazardous weather outlook product that a few of the weather offices are testing, and that looks to be going into effect sometime in the near future with all the weather offices. So Andrew from Blacksburg will be our guest next week On the 2nd of May, we're going to be talking about the Greensboro tornado with Tim Buckley. I think Taryn Kirksey is going to be joining us. We're trying to get someone from the Raleigh office as well. And if that doesn't work out, we're going to try to get the Greensboro emergency manager on with us to kind of talk about that. And then let's see, on the 9th, we have the global lightning mapper from Dana Griffin from Huntsville, Alabama, the weather service there. Eric got that show booked up. And then on the 16th, we're going to be talking about disaster preparedness with a meteorologist, Cheryl Nelson. So that's kind of what it looks like over the next couple of weeks here at the Carolina Weather Group. And as always, if you have any suggestions or anything like that, please feel free to reach out to any of us here on the panel. And we'll try to do our best to get those shows created and for you. In fact, we had one this morning ask about doing a show on the Greensboro tornado, so we were able to get that booked in today. So if you have any suggestions or any guests you'd like for us to bring on, feel free to reach out to us, and we'll try our best to make that work. So with that, we thank you again for watching us here at the Carolina Weather Group, and we welcome you to watch us every Wednesday night at 8:15 Eastern Time, 7 p.m., 7:15 Central Time. We're on almost every Wednesday night, so make sure you share the word, and we'd love to have you as a full-time viewer. So until next week, we hope you have a great week. Enjoy the calm weather, and we'll see you back here on the Carolina Weather Group next Wednesday night.
Cool.
Clear?
Yay.
Hey, you know what I want?